4 irreducible kinds of matter make up everything that exists. There's earth and all things solid, water and the liquids, air and other gases, and fire with its light and heat. This had been established as fact thousands of years ago, espoused by philosophers from Greece to Japan and everywhere in between. This was taught to children and employed in medicine. In short, trying to upend this philosophy would be bold, to say the least. So in the 18th century, when Antoine Lavoisier combined a flammable gas with oxygen to create water, he named this gas in a way that explicitly opposed classical elemental theory. He called it water former. But that sounds kind of clumsy, even in French, so Lavoisier translated the name into Greek, giving element 1 the name you know it by today: hydrogen. You're listening to the Episodic Table of Elements, and I'm T.R. Appleton. Each week, we'll take a look at the fascinating stories behind one element on the periodic table. This week, we're taking a look at element 1, hydrogen. An atom is the smallest piece of an element that exists. The only amount of hydrogen less than one atom is no hydrogen at all. But that atom is still made up of other smaller things. It's sort of like how an axe is made of a handle and a blade. You could separate those two things, and then you'd have a handle, and you'd have a blade. But neither one of those is an axe on its own. It would be pretty hard to chop wood using either piece. Like our metaphorical axe, one atom of hydrogen consists of two smaller bits. One proton, which sits at the atom's center, surrounded by one electron. The proton has a positive electric charge, and the electron has a negative electric charge. They're attracted to each other by these opposing charges, like the opposing poles of a magnet. The center of the atom, where the proton lives, is called the nucleus. And that proton is pretty important. It's what makes our atom hydrogen. If it had 2 protons, it would be helium. If it had 6 protons, it would be carbon. The number of protons in the nucleus is called the atomic number, which can be a handy way of referring to an atom other than its name. So hydrogen, with 1 proton in its nucleus, has an atomic number of 1 and can be called element 1. By the way, I did say that 1 electron surrounds the nucleus, and that's probably the best way to think of it. Even though an electron is much smaller than a proton, it's moving so unimaginably fast that it forms a shell around the nucleus. This is kind of like when the individual blades of a fan spin so quickly that they appear to be a single hazy circle. So there's our first element of the periodic table: hydrogen, with 1 positive proton in its nucleus, 1 negative electron surrounding it, bound together by opposing charges in a neat little package. It should be easy to find where it belongs on the periodic table, right? Unfortunately, it is not. Remember how elements in each group are supposed to be similar to each other? Well, sometimes hydrogen behaves like the elements in the first group: lithium, sodium, etc. All those elements can be explosively reactive under common conditions, as we'll see in a few minutes. But that also doesn't quite fit. All those other elements in Group 1 are solid metals. Group 17 contains a couple gases, fluorine and chlorine, and like hydrogen, they're highly reactive. Placing hydrogen above them would make sense, and would also put it right next to helium, the only other element in period 1. But it's not a perfect fit. Sometimes hydrogen actually resembles carbon, and those two elements alone can combine in nearly infinite ways. You're familiar with some of them: oils, plastics, rubber, and many, many more. To be clear, this is not exactly a huge controversy in chemistry. Scientists are well familiar with the peculiarities of nature's simplest atom, and they either shuffle it around as needed or just keep it separate from the other elements in their heads. But why keep it separate in your head? Since hydrogen isn't quite like anything else, sometimes it's placed in the very middle of the periodic table, floating above all the other elements. And that kind of makes thematic sense, too. When it's present as a pure gas, hydrogen really does float above all the other elements. By virtue of being the simplest atom, it's also the lightest. And once hydrogen became easy to acquire in the 19th century, that's exactly what made it so desirable. Flight has eluded humanity for most of our history. We could walk the earth and sail the seas, but the skies were the exclusive domain of the wind and winged beasts. For a long time, many saw this as the right and natural order of things, not something to be overcome. In Greek mythology, Icarus defied the gods and flew on wings of wax. Being a mere mortal, unaccustomed to the sheer joy of flight, he became reckless and flew too close to the sun. His wings melted, and he tumbled into the sea. The story is often read as a tale of hubris, but some people heard a challenge to succeed where Icarus failed, and by the 1700s, they were making progress. That was also about the time scientists had discovered that when air is heated, it becomes less dense, making it lighter than the surrounding cooler air. If you can contain that lighter air, say in a balloon, it will rise into the sky. This same principle powers hot air balloons today. Balloons improved incrementally for about 100 years after their invention, but they were mostly a curiosity for the wealthy. They started to see applied use during the American Civil War. A man named Thaddeus Lowe had convinced President Lincoln that balloons could make excellent surveillance tools, and he suddenly found himself organizing the Union Army Balloon Corps. With Lowe's fleet of 6 balloons, the Union Army had a literal eye in the sky above battlefields, sometimes with a telegraph operator providing real-time updates on enemy positions and developments. When one of these balloons was launched from the deck of the USS Fanny, it incidentally made the little steamboat America's first aircraft carrier. Unfortunately, many of the higher-ups in the Union Army saw the Balloon Corps as an embarrassing carnival attraction. The Balloon Corps was disbanded in 1862, but one of the balloons, and its original operator, John Steiner, were enjoying a second life in St. Paul, Minnesota, offering rides for thrill seekers. And right about that time, along came a young German tourist named Ferdinand von Zeppelin. Steiner offered von Zeppelin a solo flight in his balloon, and by all accounts, the flight was quite pleasant, rather unremarkable. But soaring above the Twin Cities made a huge impact on the young man. He would spend decades daydreaming about that very flight until, in 1900, Ferdinand von Zeppelin finally manufactured the first of the flying machines that would be inexorably tied to his own name. Zeppelins are airships with a rigid body, unlike a hot air balloon, which needs to be inflated. This allows them to be built much larger and withstand strong winds. Zeppelins were primarily employed as air weapons during World War I, but they enjoyed a peacetime renaissance as passenger vehicles in the 1920s and 30s. Airships circled the globe, ferrying the rich and famous among cosmopolitan locales like Frankfurt, Rio de Janeiro, and New York. One even made a 7-day voyage to the Arctic. By the 1930s, the Zeppelin had become a grand symbol of German pride. Coincidentally, national pride was becoming a very big deal in Germany at the time. Joseph Goebbels was as big a fan of Zeppelins as any German. He was also the Minister of Propaganda for Nazi Germany. So when construction began on the largest, most impressive Zeppelin yet, he had a name in mind for the airship: the Adolf Hitler. That decision was not his to make, however. The Zeppelin Company was still a private corporation, and its leader, Dr. Hugo Echner, had a distaste for the Nazis. He insisted that the record-setting airship be named after a previous German leader, Paul von Hindenburg. The Hindenburg was a truly impressive ship. To this day, it remains the largest flying object in human history, on a scale that's difficult to grasp. It was about as big as 2 American football fields stacked end to end. A Goodyear blimp, the kind that typically soars above those fields, could comfortably float inside the Hindenburg's balloon with plenty of room to spare. So could a second one, and probably a third. The reason the ship was so big, aside from the grandeur of it all, was because German engineers wanted to ensure the safety of their passengers and crew. Nothing provides lift as efficiently as hydrogen, but it has a major drawback. It is highly explosive. The Zeppelin company was going to avoid this problem by using helium, a gas with the benefit of being entirely non-reactive at the expense of being slightly heavier. Thus, it requires a little more helium to lift the same mass in the air. Everyone agreed that this was a worthwhile trade-off and a good plan. Unfortunately, it was not a plan they could execute. In the 1930s, helium was extremely difficult to acquire. The United States had a virtual monopoly on the world's supply, and they weren't about to loosen that grip just because the Germans wanted to inflate a big balloon. This was discouraging, but not a fatal blow for the Hindenburg. The Germans would simply have to fall back on that old standby, hydrogen. It was more dangerous, yes, but Germany had decades of experience flying hydrogen airships and had never even suffered a single injury. Everything was going to be fine. "1936 was a good year for the Hindenburg. It made 56 flights, crisscrossing the Atlantic Ocean several times. One of its ports of call was Lakehurst, New Jersey, just 50 miles from New York. And while the ship had avoided being named after Adolf Hitler, it was still a ship built in and partly funded by Nazi Germany. A particularly unsettling photograph taken on May 6, 1937, shows the Zeppelin flying in a perfectly clear sky, swastikas emblazoned on its tail fins, just above the distinctive Manhattan skyline. I'll post this photo so you can see it for yourself at episodictable.com/hydrogen. But that was not the most famous photograph taken of the Hindenburg that day. It's not clear exactly what happened, but at some point, when the Hindenburg tried to land at Lakehurst, something went terribly wrong. A gas leak and maybe a spark of static electricity were all it took to set the entire craft up in flames. Fully loaded, with 97 passengers and crew, the airship crashed to the ground in a great conflagration, a spectacle that was captured by newsmen on the scene. Most famous of these was Herbert Morrison, a journalist for Chicago News Radio.
It's starting to rain again. The rain had slacked up a little bit. The back motors of the ship are just holding it just enough to keep it from... It bursts into flames. Get it started. It's crashing terrible. Oh, my, get out of the way, please. It's bursting into flames, and it's falling on the mooring mast and all the folks between it. This is terrible. This is one of the worst catastrophes in the world. Oh, it's like 400 or 500 feet into the sky, and it's a terrific crash, ladies and gentlemen. The smoke and the flames now, and the flame is crashing to the ground, not quite to the mooring mast. Oh, the humanity.
This was a watershed moment in media history. Although the coverage was not broadcast live, it was heard worldwide, and often alongside photographs and newsreel footage of the catastrophe. For the first time, a tragic accident was more than a momentary disaster. It became a cultural experience, shared with people who had been far from the scene of the actual incident. Incredibly, 62 people survived the crash, but the Zeppelin industry did not. These graphic images and sounds were too horrifying for the public to bear, and the golden age of airships was over. Hydrogen, however, would soon be flying even higher. It's very difficult to go to outer space. A tremendous amount of energy must be spent to escape Earth's gravitational pull. Every kilogram of material costs tens of thousands of dollars worth of rocket fuel to bring along. Additionally, carrying the extra fuel to lift that payload causes the rocket to weigh more, which means the rocket requires more fuel. And that makes the rocket weigh even more, requiring even more fuel. All of that is to say that when going to space, it's very important to use a fuel that provides, quite literally, the most bang for your buck. Hydrogen's light weight was what made it so valuable for balloonists, but they rightly saw its highly explosive nature as a dangerous risk. NASA scientists, on the other hand, saw these two factors as a perfect combination for rocket fuel. Liquid hydrogen is not the only chemical used to fire stuff into space, but it is one of the most effective. We send a lot of different kinds of things into space. GPS and communication satellites, and Mars landers, and even other people. But in 1946, what physicist Lyman Spitzer wanted to put in orbit was a telescope. That might sound a little strange. Why bother sending an expensive, fragile telescope to space instead of just building a big one here on Earth? Terrestrial telescopes are great for looking at objects that are relatively close to Earth, like the Moon or other planets in the solar system. But when trying to observe bodies farther out in the Milky Way and beyond, the job becomes a lot tougher. Factors like light pollution and atmospheric refraction and bad weather all make it extremely difficult to get a clear picture of these dim and distant objects. Coincidentally, the vacuum of space suffers none of these problems. So, under Spitzer's guidance, NASA proposed the Hubble Space Telescope, named after legendary astronomer Edwin Hubble. The project spent most of the 60s and 70s in various committees until funding was finally secured from Congress in 1977. Design and construction began in earnest, and the team worked diligently toward an anticipated launch in 1983. It was arduous work that needed to be done. The workers of the Perkin-Elmer Corporation had a 1-ton slab of glass that they needed to cut, shave, and polish into a mirrored surface more precisely than anyone had ever done before, accurate to millionths of an inch. The Hubble's mirror needed to be so immaculately smooth that if it were the width of the Atlantic Ocean, all the waves would be less than 3 inches tall. It was perhaps inevitable that such demanding requirements would result in delays. The launch was pushed back to 1984 and then 1985. The telescope was finally actually ready for launch in 1986. But when the Space Shuttle Challenger exploded in January of that year, all planned missions were scrubbed until further notice. For the Hubble, this meant it would remain Earthbound until April 1990. After such a long wait, NASA was champing at the bit to show off what their new toy could do. A public relations officer invited the press to witness the transmission of Hubble's very first photograph. This was not standard operating procedure. The image was likely to be the most unremarkable photograph it ever took, just a test of the optics systems. Nonetheless, there was much fanfare surrounding that first look out of Hubble's eye. Unfortunately, the photograph was quite remarkable, for how bad it was. Stars that should have appeared razor sharp were far from it. Someone in the crowd asked, "Is that the way it's supposed to look?" NASA was able to play this off in front of the cameras, but away from the media, they were reeling in panic. Scientists on the ground tried every trick they had to improve the picture remotely, even trying to bend the mirror ever so slightly, but nothing worked. Finally, an investigation found that a tiny spot along one of the edges had been polished just a little too much. It was too flat by a few nanometers, about 1/50th the width of a human hair. A single 4-inch wave on the Atlantic Ocean. This was a crushing blow. NASA took a beating in the press, everywhere from news magazines to late-night comedy shows. It was the last thing that the struggling and underfunded space program needed. Astronomers used the broken telescope as best they could, but it was like driving a car with a spare tire. It just couldn't do everything it was supposed to do. But this research was enough to keep the telescope from being abandoned outright. And that bought NASA just enough time to come up with a fix. The proposed solution was surprisingly straightforward. Much like an eye doctor prescribes glasses to a person with vision problems, NASA scientists similarly devised corrective lenses that would restore Hubble's vision. Now the only problem was that the glasses were on Earth, and the eyeball was 353 miles overhead, flying 10 times faster than a speeding bullet. On December 2nd, 1993, almost 4 years after Hubble's launch, astronauts aboard the Space Shuttle Endeavour began their mission to fix the Hubble. As one New York Times article read, "So many things could go wrong, and so much is at stake." Although top NASA officials have sought to play down the stakes involved, nearly everyone else looks upon this as virtually a do-or-die mission for the space agency. The reason for this was because NASA had endured a number of recent public failures, even aside from the blurry telescope and the Challenger explosion. Minor problems with satellites and antennas were cumulatively embarrassing, and recently a $1 billion Mars orbiter had simply vanished without a trace. Many people were worried that one more failure would do the agency in for good. The Endeavour's mission was not an easy one. It required a record-setting 5 spacewalks over 11 days, performing delicate, complicated tasks, all while wearing a spacesuit that makes it exhausting just to move. The astronauts completed their mission without incident, but no one knew whether they had actually fixed the problem. Astronomers huddled around a screen with bated breath to see the first new image from the Hubble. There were no reporters at this event. The photo that appeared on NASA's screen was one of a single star in the very center of the photograph. That star was crystal clear. It was a huge relief to everyone in the room. Half a century after Lyman Spitzer proposed his space telescope, humanity could see the universe with newfound clarity. Finally, NASA had a public victory. The Hubble would go on to take hundreds of photographs that would amaze the viewing public. It would capture entire galaxies colliding in slow motion, photograph nebulae that looked like enormous watchful eyes, and peer so deeply into space that it revealed a time when the universe was brand new. But perhaps the most famous photograph the Hubble ever took is one that makes an appropriate place for us to end our journey. Only a few months after its repair, the telescope turned its eye to a region of the Eagle Nebula, revealing enormous columns of hydrogen gas towering light years high. The image was poetically named the Pillars of Creation, and that's quite appropriate. A collection of hydrogen gas like this is sometimes called a stellar nursery because over time, that hydrogen will coalesce and condense under its own gravity, culminating in a series of bright nuclear explosions that herald the birth of a new star. In the hearts of those stars, heavier elements are forged. But that's a discussion we'll save for next time with helium. Some people enjoy collecting stamps, in a pursuit that's known as philately. Others prefer to amass a collection of coins, a hobby known as numismatics. But perhaps neither of these piques your interest. You'd like to get involved with something a little more exciting, a little more dangerous, something that requires studying a little bit of chemistry. Well, element collecting is just the hobby for you. Unfortunately, it doesn't have a fancy esoteric name, but give it time. It's still pretty new. It's also one that's fraught with difficulty. Some of these elements are highly regulated or highly toxic. Others are difficult to tame, with a radioactive bite that extends beyond any cage that can contain them. Well, for you, I'm here to help. Each week after we look at the science and history behind one particular element, I'll let you know what your best bet is for acquiring a pure sample for your collection. And much like hydrogen makes a great entry point for learning about the periodic table, it's an easy place for the newfound element collector to start their stockpile. Most elements need to be sourced secondhand. Neon from electric signs, for instance, or americium from old smoke detectors. But hydrogen is the only element that you can actually create wholesale in the comfort of your own home. You might not think of it this way, but you have a ready supply of hydrogen piped right into your kitchen. It's just all bound up with oxygen in the inconvenient form of water. All you need to do is crack that H2O into hydrogen and oxygen. I'll include a link to full instructions in the show notes on episodictable.com/hydrogen, but it's a surprisingly simple process called electrolysis. At the bare minimum, all you need is a 9-volt battery, a bowl of water, and 2 paper clips. Bend 1 paper clip around each terminal, positive and negative, and dip the ends of the paper clips in the water. This will make an electric current flow directly through the water, and bubbles will form around the submerged paper clips. The paperclip attached to the positive terminal will gather oxygen, and the paperclip attached to the negative terminal will create hydrogen atoms. The hydrogen paperclip will gather twice as many bubbles as the oxygen paperclip. This is because water is composed of twice as much hydrogen as oxygen, H2O. If you fill a bottle with water to prevent mixing with ambient air and then slip it over the negative paperclip, you can collect the hydrogen for safekeeping. Congratulations, you are now an element collector and have created a sample of nature's simplest atom. Hydrogen accounts for 3 out of every 4 atoms in the universe, mostly in interstellar clouds like the pillars of creation. But these are yours. Theodore Gray is a researcher and author who's responsible for much of the recent popular interest in chemistry. His book, The Elements, is a gorgeous exploration of the periodic table. I'll be pulling a lot of information from it, and if you enjoy this podcast, it's absolutely worth picking up. His website also provides a wealth of information about the elements, including some tips on how to make this electrolysis setup more efficient, and some important safety notes to go along with them. I'll provide a link to this, as well as much more fascinating information that didn't quite fit in this episode, at episodictable.com/hydrogen. Thanks for listening to the Episodic Table of Elements. Music is by Kai Engel. To see images and watch videos, read episode transcripts, and comment, visit episodictable.com. Next time, we'll keep things light with helium. Until next time, this is T.R. Appleton reminding you not to fill your passenger airships with highly explosive hydrogen.